Show that there is only one point of inflection on the curve. Use mathematical reasoning to justify your response. Okay, so if we're looking for one point of inflection, we're not looking for a stationary point of inflection. The point of inflection is where you start going from a max to a min. It's this point in here. It's different to a stationary point. Stationary point is just where you notice a change in the gradient. So that's why we're testing that the second gradient, or the second derivative, is equal to 0, and then we're going to find some factors. Okay, so let's get started. If y is equal to this, then y dash is equal to this. The 3 comes down, knocks out the other 3, so it'll still be 10x. Okay, and then that means that y double dash is going to be equal to this. Okay, so from this point, it's hard because they're all big numbers. So I'm going to factorise a 20 out. And I'm going to let this equal to 0 because I'm going to start trying to solve for where that stationary point, where that point of inflection is. Okay, so now that I've got to this point, I can take that over and try and cancel it out. See ya. Now I'm left with this. And we're going to have to try and find a value of x to make this statement true. So like I always say to you in class, chances are the number is between -2 up to +2. Always start with 1 because mathematicians are lazy, and when they write these exams, they don't want to take too long for you to find it. So 1 cubed is just 1 plus 3 times 1 plus 1 minus 5. There you go, it's 1. So, therefore, x equals 1 is a root. So, x minus 1 is a factor. Okay, so you're going to hate this, but the next thing we're going to do, because now I know that that's one of them. X minus 1 is one of the roots multiplied by something else in there equals 0. So as soon as you see it in this form, you should be thinking, remember all that fun we had learning to factorize by long division? This is one of my favorite things. Okay, so we're going to be factorizing. Now, we're not factorizing our original expression. We're still trying to solve for the roots that make this statement true here. So we've taken the 20 across. Really, currently, the factorizing is like 20 times x minus 1 times something else equals 0. And then I can use null factor rule to find out what these are. So I'm factorizing this expression. That's what we're doing our long division on. Okay, so first things first, that first term, that divided by that leading term there, gives me this. Now, the thing that's getting factorized out is this. What I'm subtracting here, that should have a squared there. Whatever the product of this is goes up here. And now I'm going to do what's left over here, this x cubed minus x squared, that is getting subtracted here. So minus x cubed minus the negative x squared. So minus negative x squared is going to change that into a positive. So now I'm going to have these two will cancel. It should always cancel. If they don't cancel, something's gone wrong. 3x squared plus x squared makes 4x squared plus x minus 5. Now we do it with our next term. 4x squared divided by x equals 4x. So plus 4x. Okay, and then that is going to multiply what's at the front there. So that'll become 4x squared minus 4x both of those terms are being subtracted. So this one minus that one knocks it out. This minus the negative that changes it into a plus. So it's going to become 5x, positive 5x, and then the minus 5. One last time, over x, that turns into 5, and then we'll subtract that, so plus 5. So then that'll turn into 5x minus 5, and we subtract, turning that into a plus, subtract that, meaning that there is a 0 remainder here. So my equation really looks like this. 20x minus 1, x squared plus 4x plus 5 equals 0. Okay, so we're at this point here. Now, this is the part that people will screw up. Remember, it's got to add to give you the middle number and multiply to give you the end number. The factors of 5 are 1 and 5. That adds to give you 6. That means there's no nice factors here. So we could try our luck at popping this into the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, the whole point of this formula here is really this part underneath. This is called the discriminant, and it helps us know something. If it ends up to be a positive number, I've got the plus minus here, which means I have two solutions. So if it's positive, your answer underneath that highlighted section is positive, 2 roots. If it equals 0, that's 1 root, because you're only left with the remaining front part. If it is a negative, then you have no roots. So then that means that that would be our only factor. So 4 squared is 16 minus 4 times 1 is 4 times 5 is 20. So minus 20 gives you negative 4. Therefore, no root. So now I can state over here, therefore only one factor or one point of inflection at x equals 1. Discriminant is what we call that highlighted blue bit. Discriminant is a negative, so then that means it is less than 0, therefore no roots. Something like that. And you'll see they talk about the discriminant when they do their answers for QCAA.